When looking for a surge protection device, there are a lot of options to consider, but the first consideration should be given to peak surge capacity. Did you know that the level of peak surge capacity not only determines the surge protection device surge handling capabilities, but peak surge capacity can also be an indicator of useful life? Today, we're going to discuss all the considerations related to peak surge capacity and useful life for a surge protection device. Hello, and welcome back to the Power Grid, a podcast to help you build reliability in your electrical system and give you confidence in your power. I'm Brian Brannigan with Power Protection Products. We have been solving power quality problems for almost 30 years. We are your trusted advisors for critical power, cooling, and energy solutions. When it comes to selecting a surge protection device, peak surge capacity is a primary consideration. Determining the surge capacity can be challenging based on the manufacturer's calculation, the modes of protection, and the configuration inside the unit. Surge protection devices come in a variety of sizes and features. High peak surge capacity can not only mitigate large power surges, it can also increase the lifespan of the surge protection device. By having a more robust protection circuit engineered in the surge protection device, the life and warranty of the surge protection device can be increased. One time in the late 90s, we got an order out of Texas for 8 surge suppression units. These surge suppression units were rated for 80 kVA. They all went into a manufacturer's facility in Texas, and we had no idea that 80 kVA on the service entrance was not big enough to handle the surge exposure that these units were going to be exposed to. And it wasn't long before all 8 of those surge suppression devices became warranty claims because they were not sized correctly for the service entrance of that particular facility. And that's why today we're going to talk about the proper sizing for peak surge capacity when picking out a surge suppressor. Surge suppression KA rating selection depends on a variety of factors. The first factor is exposure level. Higher exposure will mean higher KA rating for the surge suppressor. In fact, IEEE has 3 surge categories based on the area that the surge suppression device is going to be installed in. The next consideration to peak surge capacity for a surge suppressor should be the exposure to external surges, things like lightning frequency. If you live in a high-prone lightning area, you're going to be exposed to a lot of peak surges. And so it's important to look at the placement of the surge suppressor and what part of the country the surge suppressor is going in. Other considerations should be the relative value of the equipment that's being protected and even the relative value of the downtime if the facility does go down due to a power surge. Surge suppression devices are sold by surge ratings measured in KA. The more surge current rating you have, the more money it's going to cost. Over time, these ratings have climbed. For example, a 20 millimeter metal oxide varistor can handle a 12 Ka rating, or a 40 millimeter MOV can handle a 40 Ka rating. But typically, 20 millimeter MOVs are used up to about 100 Ka per mode, and a 40 millimeter MOV would be used for higher Ka per mode applications. To increase surge ratings and to stretch the use of the lower cost MOVs, it's common to parallel MOVs. There are differences between an MOV and a silicon avalanche diode. It's a myth that MOVs degrade and have poor life expectancies. The fact is that MOV technology can survive in excess of 25 years in high exposure levels and can survive service entrance surge events. It's also a myth that silicon avalanche diodes have a faster response time. The fact is that MOVs and silicon avalanche diodes respond 1,000 times faster than a surge event. Response time is not a recognized category by IEEE or NEMA. Did you know that there are 7 modes in a Y system for a surge suppressor? There are 10 modes in a 3-phase Y surge protection device, but generally the line-to-line is not used. So you must connect all 7 remaining modes to each other in a surge suppression configuration. Your first mode would be line to ground. So you'd have phase A to ground, phase B to ground, phase 3 to ground. That's 3 modes of protection. You'd also have line to neutral. So you would have line A to neutral, line B to neutral, line C to neutral. So there's 3 more modes of protection. And then there's neutral to ground mode, which is another protection. So that combination makes 7 modes of protection for a surge suppressor. Some companies also throw in a line-to-line protection mode, which would be A to B, B to C, and C to A, and that would add up to 3 modes of protection for a total of 10 modes. The last 3 modes that we talked about, the line-to-line, really isn't necessary because it's never going to get past the line to neutral and the line to ground to go into the line-to-line. There are 5 points and 7 connections when looking at a surge suppression schematic. You have line A, line B, line C, and then neutral to ground in a Y system. And it's important to understand where the surge suppression is and how much Ka peak surge capacity we have on each point of the connection. So, IEEE does have surge location categories. Category C would be for high exposure locations, things like large service entrances, distribution panels, rooftop locations, or outdoor locations. There's also a category B for medium exposure locations, some service entrances, distribution panels, short run branch circuits from the service entrance. And then there's category A for low exposure, branch panels, long run branch circuits from service entrances, and point of use disconnects. On the category C high exposure locations, you can typically see a peak surge capacity range anywhere from 250 to 300 Ka. That's not uncommon at all. And the same can be said for a motor control center. In the category B medium exposure locations, you can see surge suppression ratings that fall much less, something like 80 Ka to 160 Ka. And then in some certain panels, you can see surge suppression ratings drop down to 80 Ka to 120 Ka. There's a variety of low exposure category A location surge suppression devices to consider. So a brief overview of surge protection device Ka ratings would include, first of all, surge protection devices are rated for a lifetime in Ka, not performance. For example, 100 Ka or 120 Ka or even a 200 Ka per phase surge suppressor will last a long time put in the correct environment. The let-through voltage is a performance measurement and does not improve or decrease with the Ka rating. So the bigger the surge suppressor you have is not going to make a difference on what the let-through voltage is going to end up being on the surge suppressor. A higher Ka rating provides the surge suppression device with the ability to withstand a higher number of Category 3 surge events. Effective surge lifetime ratings should be based on the geographic location and the life expectancy of the surge suppression, which is usually about 25 years, and that matches the distribution system. If you were to take a 100 Ka surge suppression device and hit it with 10,000 amp surge for about 8,000 times, you would start to see a degradation in that particular surge suppressor. But if you took a 250 Ka per phase surge suppressor and hit it with the same surge, 10,000 Ka surge, it would last 12,000 times before we started to see the degradation in the unit. So the bigger the unit, the longer the life of the surge protector. Although rare, lightning surges are the highest magnitude and the most damaging surges a surge suppressor will ever see. Empirical data has indicated that surges above a category C3 or 10 kA, 20 kV rarely or never exist inside a facility distribution system. Selection of a surge protection device KA rating should be based upon geographic location first. Then, if you're staging your surge protection devices downstream, the placement of the surge suppression device can also determine the lifetime rating. Remember, a higher surge protection device KA rating does not mean lower let-through voltage, but does mean increased lifetime in the surge suppression device. A 250 kA rated surge protection device will provide at least 25 years of lifetime. Even in high lightning surge locations such as Florida, a 600 kA surge suppression device would provide a 200-year rating, which is highly excessive and costly. Thank you for joining us today on The Power Grid. Selecting the proper surge protection device for your application can be challenging. Determining the right peak surge capacity can have a huge impact on performance and longevity. Call Power Protection Products or check out the show notes to learn more.